under the same condition.
Agree. So yes, it is. So getting the same result repeatedly. So yes, one of the very famous, you will see this, if you read the Norman, they have explained reliability as a big elephant. Okay. So imagine, I could not post that picture, but you must have read all that story. If there are 6 blind people, and if they touch the elephant, one person says that it's only touching, that it's the ear, the other person only touching the feet, saying it's a pillar. The other person is only touching the ear, saying that it's a sort of soup, and the other person is touching the nose, saying it's a kind of a other thing. So perception of people regarding reliability, he has explained it very well. It is like 8 blind people touching elephant and interpreting it in their own way. So similarly, he has also said the same thing, that if I ask this, all of us, you will write that repeatability or reproducibility or getting the same result. But actually in scale, reliability is not the same thing which we have done earlier. So we'll see what is reliability in context of the scale. Okay. So see this thing. This again, this you will find as reliable here. The same thing which you have done it earlier, or you are telling me now. So what you can see in this picture? Yes, please write.
Clock.
Yes, clock showing the time at 6. Very true. So this is scenario 1. Every day you set your alarm clock at 6, and every day the alarm clock rings exactly at 6 a.m. without fail. Okay. Now, do you think that validity needs to be checked? Because there might be a case that you don't know about the actual time. So can you say that your alarm clock is reliable, but you need to check the validity because it might be 6:30 actually, or 6:10 or 6:15? Like, this is scenario 2, that if clock is not correctly set to the actual time, say it is 10 minutes fast. So will you say that the validity is compromised? So now there are 2 terms here. One is reliability and the other is validity. So reliability is every day the clock is giving you the same time, ringing at the same time. But if its actual time is 10 minutes fast or slow, then its validity is compromised, but it is reliable. This is the third scenario. If the clock is not correctly set to the actual time, let's say it is 30 minutes fast or slow. It can be, like previous case, it was 10 minutes, here it is 30 minutes. So this 30 minutes is the error in the validity. So this error, 10 minutes is larger or 30 minutes is larger? Definitely 30 minutes is larger. So here the validity is compromised. And if the clock is correctly set to the actual time every day, and your alarm clock rings exactly at 6 a.m. without fail, what will you say? You say that it is reliable as well as valid. So this is question for all of you. Can reliability exist without validity?
Yes.
Yes, because you can get the same time every day, but it may not be the true time. The similar is the concept with the scale. The scales, the item which you have generated, it might be a very reliable one, means they all are measuring the same construct, but it may not be the construct which you have defined or which you have thought of. So that's the difference between the validity and reliability. So that's why reliability studies are done before validity, before checking the validity. And here I mean validity by the construct validity. The content validity which you have just learned, that was not the construct. Here, the validation study in case of a scale, we mean by the construct. And I forgot to tell you regarding one important validity, which is the face validity. That is also related to content validity. So whenever you see an item, without having any background or without having any reference, if you just see the item and you say that it is relevant or not, then it is known as the face validity. Just by seeing the face or by seeing the wordings of the scale, that is known as the face validity. So this face validity and content validity we do before the reliability. But once you have decided on the number of items in your score, you check, then you take the data, you do the data collection and you do the reliability testing. So yes, you are right that reliability exists without validity. So now, can you apply the concept of error in the above scenario? So there are four scenario: scenario 1, 2, 3, and 4. So you can say that in case of the scenario 2 and 3, there is error, but in scenario 3, the error is more, and in scenario 2, the error is less. So now we will understand the concept of reliability in context of these items. So again, since we are working on the construct empathy, if I have decided these items, item number from 1 to 5 on a scale, and then I see item number 1 is saying, I feel sad when I see someone suffering. The second is, I try to help people in need whenever I can. So these are the 5 items. So now suppose there is a person where the true empathy score is 4. 4 means this is the true score. True score is not known. Remember, this is just for conceptual process I'm telling you. Generally, true score of a person is not known because that's an abstract construct. Through item, you are trying to measure, go as near as possible to the true score. So there will be an error. So ideal scale, what will be an ideal scale? Where each item, because one item, there are 5 items, but I expect that each item should measure my construct, which is the true score. So my construct is empathy. And if the ideal item, each item, the observed score is 4 in all the item. So what will be the error? Error will be what? The mean is 4 and there is no variance. So there is no error in this case. Okay. Now coming to another scenario. Suppose again here the true score is 4, but the individual item observed score on this person, it is 3. Again, it is 5 in item number 4 and 3 is item number 5. So what will be the error from the true score? It will be -1. There is no error. It will be +1 and -1. So these are the error. Okay. So this will be a practical scale where you can see that there are minor deviations from the true score. Now see this. So what can you see in this picture? There are 4 people. So this we are talking about population now. Initially we talked about people, individual. Now we are talking about person. So this is one person, second, third, and fourth. So if you get responses like this in population, so can you comment in the measurement? So we are now discussing the measurement error. Remember, yesterday we talked about measurement error. Because of this measurement error, there is your observed score will not be very near to the true score. Rather, there always be an error. So true score, your observed score will be true score plus that error. We'll see that later part of the presentation. So you can see here that individual in all those 4 individual, what do you say? Is there any error in the measurement? You can see there is a 2 true score and these 5 items, these are the item score, individual item score. Yes, you can see scenario in the population. So your responses should be definitely there is error. True. But the amount of error, is it low, high, or fair?
We need to calculate the average of each.
Just since there are only 4 items, just gross. Don't need to go for those statistical jargon, but there is a deviation. You can see 1 or 2 from the main thing. If you see the other this thing, so you can say that the error is low here. There is error, but it is low. When you see this or fair, depending on your, now coming to this, then I think you will understand. If you take this as a reference, then you can see like whether the error is high or fair. So it is high. So this is just to make you people perceive regarding the deviation from true score. So there can be population where the deviation from the true score is very high, and there can be a population where the deviation, there will be deviation from true score, because you can never measure a person's true score. Like we say in the population, this thing that you cannot measure the population, you can only project by the way of your sample statistics. So similarly, if you see that these errors, they contribute to the overall reliability of the scale. So in case of reliability, if the error is small, when the differences between the observed score and true scores are very small, we consider that scale to be reliable in that population. When the errors are very large, then we call that the scale reliability is, it decreases in that population. Okay. So, Dr. Seetal, we are not quantifying right now. If you see this, we are just trying to have a general idea how much deviation. So, like, let's say if you see this, it is deviating only like 1 or 2. Okay, ideally it should be 5 for everyone. But if you see the other situation, you see that here there is a difference of 4. There is a difference of 3. So difference is more. So only on the basis of just seeing it and without calculation, this is just to make you people feel that if the error is high, and what is the error? Error is the difference between the observed score and the true score. If it is high, then the scale will not be reliable. So it is, I just wanted to introduce the concept of measurement error, because these all are due to the measurement error. The item which you have selected, or the response format which you have selected, or the person who is answering, probably he has not understood the item correctly. So whatever he is measuring, whatever he is answering, there's a deviation, and that you can say that the scale reliability is not good. Now, again, I will come back to the yesterday's concept of variance. So again, that if you just square that difference, it will be variance, because we have learnt yesterday regarding that daily mood rating. So daily mood rating over these 6 days was 6 to 5, you can say, on Monday, Tuesday, Wednesday. We did this exercise yesterday. And then we have quantified this by taking a mean, and then we have calculated the variance, because we subtracted the mean from the individual score, and then we have squared it, and we have calculated it, which is known as the sum of squared difference, which was the 19, which is the variance. So this was the variance of my mood in 1 week. Now, how this will be different from in the population? So in case this, so we have discussed that the mood is less. I think, okay. So now coming to the reliability, I inserted those 3 slides. Na? Let me see, I put 3 slides. Then only it will be enough. Okay, just let me see, okay, if I close this. This is there. Okay, actually these slides I need to unhide. That's why it was not coming. And I was surprised. Okay, so sorry. I'll again share the screen. Okay, so we did this exercise yesterday and we have calculated that mood, in this case, the variance is 0 because there was no difference. So variance in response and reliability of a scale in population, let's say if you calculate this in the form of a job satisfaction, the construct is job satisfaction, and I have taken this on a 5-point Likert scale. So suppose most of the individual from population 1, 2, and 3 responds this way. In population 1, you get a score like one person was saying that how to avoid this. Like most of the people, they have given a neutral response. Everyone has given free. And we are talking about the population now. We are not talking about the person. In population 2, the people have responded like this for all these 5 items. So they have scored like 2 in first item, 3, and similarly, these scores are there for individual item. So if you calculate variance using the formula which we have told, and this variance, you will get it in the software. You don't need to do it. So variance is 0.4. And in population 3, if you see the individual score, it is 1, 2, 3. So it is deviating, like everyone is having like deviated score. And someone is saying 1 in this score and someone is saying 5 to this. Okay, so this variance is how much? 2.5. So what is your interpretation? In which case the reliability is more? Which population?
The variance is less. Population 1.
Variance is, yeah, 0. It is very good. Scale is highly reliable. And what about population 3? It is not reliable at all because variance is very high. So you can say that if in the population, if there are no variance or very low variance, then your reliability is from moderate to high. But if there is a high variance, then the scale is not reliable. And that high variance is due to the response inconsistency in the responses, which tells that the tool, your population is not able to understand the meaning of your item and which you have selected, and you can say that tool is not reliable for the measurement of construct in that population. So coming to this, the reliability is not of the scale. In loose term, we always say that the reliability of the scale. But basically, you should say that the reliability of the test score in that population. Because reliability will be different from one scale, one population to the other population. The reliability of a scale is not fixed. So that's why any scale you use in your population, you should report reliability of that scale in your population. So Dr. Seetal has raised her hand.
Ma'am, if we go to the previous slide that we are discussing based on that, it only based on the statistics, the variance if we say that the scale may not be the high variance, we can the sorry, what I mean to say is I ask is population 1 they gave neutral responses. Population 3 they actually gave some more varied response. So it may be the case for the population 3 that they, for the first question, they feel valued by their employer. But population 1, they didn't understand or they don't want to say answers. That's why they gave neutral response. It mostly happens in the field. So only based on the statistic, the variance, how can we discard or
This is not we are discarding that. Actually, you calculate Cronbach alpha. You don't do the actual calculation by this. But in the background, this calculation is happening. It calculates the Cronbach alpha based on the covariance and correlation concept. But this we have shown just to make you people understand how in a population that scale might act differently. Because one scale, if it is valid in one, if it is reliable in one population, it is not sure that it will be reliable in the other population also. So the reliability is the property of a test score, scale score, not the scale per se. Okay. By this, I am not discarding that scale, and I have just shown you in that population, the variance might be like this, and that will be a cause of the high reliability of that scale score, that test score in that population. Is it okay?
Yes, ma'am.
So coming to the concept of reliability, so this you can see again, this is the same, which construct it is? Formative or reflective?
Reflective.
Yes. So here it is.
Reflective.
Yeah, true. So it is a reflective construct. You can see that Y is the construct. And we explained this with the example of job satisfaction. And this X1 to X5 are the 5 items. And the direction of the arrow is saying that this construct is affecting this item. So this item is a dependent variable here. We have shown yesterday you the equation also that this item is equal to lambda into Y. Means this Y is a independent variable here. And the error terms are unique to all the items. Whereas this Y is a shared variance for all these 5 items. So now we define reliability in case of this scale. It is the true score will be, we define reliability as the ratio between the variance in true score by variance in observed score. And if you see the true score, how will you calculate the observed score? Observed score will be the true score plus error. So this denominator will be always more than the numerator. That's why you will see that reliability coefficient, which is the Cronbach alpha, we take the value as 0.7 to 1, 0.8, 0.9, and so on. So what is reliability in case of a scale? It is the ratio of the true score and observed score. Means how much variance in the true score can be explained by the observed score. So reliability, it is you will not find a scale 100% reliable. Why? Because there are measurement error. And this measurement error always leads to that this observed value will be more than the true value. So there will be always be a measurement error associated with it. So this measurement error can be there at the level of content sampling. So when you have taken the initial content validity and you have taken the initial sampling, the measurement, that error could have been there, which you can test by the internal consistency. The second type of reliability, there might be changes in respondents. Means my mental state, right? I think yesterday also someone said that if I'm not in a correct mood, so my mood is different now, maybe I will change after 1 week. So you have to test this using the retest reliability. You might, and these are usually performed when you are developing a new scale. If there is a already existing scale, then you don't need to perform this retest reliability. Rather, you only explain this internal consistency, which is the Cronbach alpha. And then there are differences across rater. So if there are 2 rater and if you are using that scale, then there can be inter-rater reliability, which we discuss using the Kappa statistics. So we will discuss the Cronbach alpha, which is the first type of reliability. So there are various types of reliability. If you are developing a new scale, you need to test all the type of reliability. That is the retest reliability, which is a type of temporal stability. And that reflects the respondent nature and mood. So how it is done? Test, retest. You give the same test, probably this empathy now, And then after sufficient time has elapsed, probably after 2 weeks, you will give this test again to the same set of respondents. And again, after 2 weeks, you can give the same set to that scale to the same set of respondents. So you are serially taking 3 observations at 0 time, then at 2 weeks, and then at 4 weeks. And then you see the correlation between the test score. If it is highly correlated, then you say that test, retest reliability, which is the temporal stability of the scale, is good. Coming to the second type of reliability, it is known as the split half reliability. That is also done in case of you are developing a new scale. What you do in the split half? Suppose if the questions are, let's say 20 item, or let's say Ayushi has done like 27 item. So what you do, you divide the scale, first 13 and next 14. And then you see the correlation between the first 13 items and next 13 items. Okay. So that is the way doing the split half reliability. What is the need of doing split half reliability? Because it is said generally you people have also said that towards the end, one person might get tired. So you want to see whether they have responded correctly for the last questions or not, the way they have responded to the initial questions. So by split half reliability, you can get this. If the correlation between the test scores are there, then you can say that there is a split half reliability. And third one is the internal consistency, which is the Cronbach alpha, which we will see together today how to do that. So again, I have done this like test retest reliability, that refers to the extent to which the individual responses to the questionnaire item remain relatively consistent across repeated administration of the same questionnaire. Or you can take alternate questionnaire forms also. Alternate questionnaire, when it will be done? Suppose you have got initial pool of, let's say, 150 item, and you have devised one scale using, if your content validity index of, let's say, 90 items are very good, but you cannot keep 90 items together. So what you can do, you can keep like 20-25 items in one set, and another alternate questionnaire you can form with another 25 items with a good content validity index. And you can see the correlation between these two also. So either you can give the 2 types of tests to the one person at same point of time, or one test at regular interval. And then you calculate the correlation coefficient, which is the Pearson's R between the 2 questionnaire. And then you can refer that as a coefficient of stability. Why stability? Because it shows the temporal stability, that the scores are persistent over time. And a large stability coefficient indicates that there is a strong test retest reliability. So generally, test retest reliability, an alternate form of split half reliability, that is done when you are developing a new scale from scratch. Probably, I think nomophobia, I don't know whether they have calculated this test retest or this or not, but ideally when you are developing a scale from scratch, you should report this test retest reliability and this split half reliability. Okay. So can we do the same test retest reliability for now in a normal, like in our case, when there is already a validated, and you are not generally, if we are not developing a scale, we are using an existing scale after language translation or probably after minor modifications, then in that case, you don't need to test for these test retest reliability. So we generally go for the measurement of internal consistency, which we measure. So I think yes. So if just for example, I just want to show. So you asked this question from students that over last 2 weeks, were you anxious and depressed? Again, here we are asking 2 questions, anxious and depressed. We should have asked one. So let's say if we have asked anxious only. So you may answer yes or no. It is in binary form. Now, if I ask this question in the form of this scale, which is again a Likert scale where I am taking like not at all several days in the form of an ordinal scale, more than half of the days and nearly every day. And the questions are, first is feeling nervous, anxious, or on edge. So this is the response of the first item. The second item is not being able to stop or control worrying. And he has answered like 0 here and here 3. Again, feeling down, depressed, or hopeless. So the answers are again 0 in this question. You can see these all questions or item, they are negative questions. So the person has scored 0 on all this and 3 high. So negative means nearly every day. Means high score will suggest that person is suffering from some mental problem or depression. Okay. Now, these are the 4 questions of PHQ4. PHQ4 is again to screen the depression or mental disorder. Now see this table and find out which respondent answer is consistent on previous PHQ4 scale. So there are 7 respondents here. 1, 2, 3, 4, 5, 6, 7. And these are the answers to the responses. You can see the questions. So 3 is nearly every day. And 1 is never, 0 is never. And these questions are like feeling nervous, anxious, not being able to stop means worrying, feeling down, depressed, and little interest or pleasure in doing things. So see this and tell us which respondent answer is consistent. So first see on respondent number 1. If you focus, he is answering 0 on item 1, 1 on item 2 and 3, and then 0 on 4. Now see the respondent. He is answering 0 on 1, 3 on item 2 and 3, and 1 on 4. And this third response, third person, 1 on item 1 and 4, 0 on this. This R4 is responding 1 to everywhere. R5 is 3 to all questions. R7 is 0 to all. So which answers are consistent? R4 and R5, 4, 5, and 7. So 7 is yes, 5 is yes, 4 is yes, but there are inconsistencies. So in which case you will find that it is most inconsistent. If you see this respondent 2, so respondent 2 is answering 3 here on item 2 and 3. So if you see 2 and 3, 2 is saying not able to stop worrying and 3 is saying depressed. So if the answer to this question is 3, means nearly every day, answer to this question cannot be 0. Because what he has responded? He has responded 0 on item number 1. 0 means not at all. So person who responds not at all to this question should not respond 3 to question number 2 and 3. Are you seeing the difference? So this is the measurement error. This we call it a measurement error. And a scale with such type of measurement error will have less reliability because it will have more variance. Have you understood this?
So is it a method of cross-checking whether the respondent is actually answering the question?
No. You cannot do. There are so many items. You cannot go serially and check for the answers. And that's why there is a statistical way, which is the Cronbach alpha. If you check the Cronbach alpha, if the measure is more than 0.7, 0.7 or 0.8, then your response is that means your test scores are reliable. This is just to tell that this is, if the responses are like this, there will be chances that the scale will not be reliable. Have you understood?
Yes, ma'am.
So ma'am, what would be your next step? Like change the items or rewording or sequence change, or what to do to increase?
Okay. You have to review all the steps. There are respondent in this context and there is a researcher in this context. So measurement error can be there from the respondent. Response also means if they are not in a state of mind. That's why I said, na, like Supriya went and they said that they will answer in a hurry. So if your scale is very lengthy and items are very like the formulation of item is difficult to understand and you have given it as a self-administered, what will you do? He will just keep on ticking. You must have done it. If the many item we also respond. But if it is very lengthy, then we try towards the end, there is a fatigue. And we don't want to like keep on, we just keep on saying like one person was saying 3, 3, 3 or some middle responses. Okay. And if you are administering, even then it is difficult for you to take the response because highly agree and agree. There is a very subtle difference. So how do you ask? So I don't know, I have asked a few people how do they ask, but when like we also conducted one study on quality of life. So in context of Bihar and in Delhi also we did. So we have understood that we should ask this highly agree by some local language. So what we used to ask that, can you recall, answer question is like this, how much you satisfied with the, with your conveyance method? So if you ask very, very, very satisfied or very satisfied and satisfied, that person will not be able to tell whether he is satisfied or very satisfied. So how to ask this? So we used to ask this like, in 1 rupee, how much paisa are you satisfied? How much paisa means, are you satisfied 0 paisa, 25 paisa, 50, 75 or 100? Something like that. And then he used to say, I am satisfied like 75 paisa or 50 paisa. Then we used to respond it like neutral if 50 or if 75 towards the higher. Are you getting the problem of taking our responses in Likert scale is not as easy as you think. It is not as easy. So you should have some measure how to, and this also you can ask from people whom you interview. How should ask? How do they quantify? Because मैं बहुत satisfied हूँ और मैं बहुत satisfied हूँ. ये कभी, whenever, even if you have to answer, you have to think twice before answering. And you don't know, so you cannot say whether the item is wrong or the person, the respondent, it is on the respondent side, not giving enough time or not taking the data properly. So you need to review your process. You need to review our process. But maybe the data collection, maybe giving more time, taking less data in a day so that you should not feel yourself tired. Many times what happens, you are in a hurry of data collection. So you take many. So that is also not advisable. And if in content validity of items, maybe wordings of item, maybe the language, but if you have used all those procedure correctly, then I think you should give time in making the respondent understand and taking time to take their responses. Have you understood, Dr. Seethal?
Yes, ma'am.
Any other question till now? Am I making myself clear up till this point?
Ma'am, I have one doubt.
Yes,
When we
Dr.
will check
Latika.
Convac alpha for suppose this scale. So are we going to calculate Convac alpha for item 1, item 2 and item 3, item 4, or we are going to do it for all the items 1L?
I will show you. Just wait for few more minutes and you
No
will
problem.
answer. I will show you how to calculate it. You will get a item-wise reliability also, and you get overall reliability. Means item-wise you get correlation. That we'll see. And then you
Okay.
see that in the table of reliability, you will have the answers to your answers. Okay. Because if I speak, you will not be able to visualize. I need to show it to you. So on the data analysis part, this is only the theoretical part which I am discussing. I'll show on the data how to do it. Okay. Yes. Any other query? If not, now coming on the number of items and reliability. So there is a relationship between the number of items and reliability. So it has got a positive but a non-linear pattern. So correlation rapidly increases or the reliability rapidly increases if you increase your items from 2 to 10. Then there is a steady increase from 11 to 30. And after 40, there is a plateau. Means there is no point having more than 30 items in your scale. So the basics of reliability, it is very important when we want to measure latent variable, because latent variable are not directly observed, but rather we infer it from the other variables. And it is important to maintain this as indicates the consistency of the survey result. And it is measured by the Cronbach alpha, and it is commonly used for the Likert questions. Now this internal consistency and reliability, it measures the extent to which the questionnaire items are interrelated. Why? Because if the items are showing high correlation, it shows that they are measuring the same construct. Again, they are showing the same construct, that means reliability is high, but it doesn't mean that it is valid also, because valid means it is measuring the true score. So we are only talking of reliability. That means there is an inter-item correlation. And if there is an inter-item correlation, we can assume that it is a measuring that, say, all the items are measuring the same construct. So consistency in the measurement of the same construct or concept, and it is estimated using coefficient of alpha, which is also known as the Cronbach alpha. The value of Cronbach alpha ranges from 0 to 1, that we have seen that in denominator, it is the observed error, observed value plus error, which is more than the numerator. That's why the value will be 0 to 1. And if there is a value of Cronbach alpha is 0, that means no internal consistency. If the value of Cronbach alpha is 1, that means perfect internal consistency. And there should be at least 0.7 Cronbach alpha, which indicates that it has got an adequate internal consistency. So the basic requirement of Cronbach alpha, it should be in a form of a continuous variable. And we take Likert scale, 5 or more. Likert is taken as a continuous variable. So it should be in the form of a continuous variable. Most commonly, it is done for the Likert item. And then coming to the unidimensional versus multidimensional. So unidimensional, you have seen the scale of GHQ12. That was unidimensional. So if the scale is multidimensional, because there are multi-factors, like in case of a WHO quality of life, then you need to measure this alpha for all the dimensions separately. Like for WHO QOL BREF, if there are 6 subdomain, there should be 6 Cronbach alpha for each domain which you will be doing. So in this case, each item is grouped together to form a scale. And if there is a one dimension like PHQ9, then there will be 1 Cronbach alpha. If there are more than 1, then there will be those many Cronbach alpha. So this is like Cronbach alpha in case of a multidimensional, and in case of a single dimensional, it will be one reliability analysis. So value of Cronbach alpha, it is a function of length of questionnaire. If your length of questionnaire are high, then definitely your Cronbach alpha is going to be high. And it increases with the increase in number of items, and it will increase with the variability of each item. Means the variability, how much response you are getting from the population, the Cronbach alpha depends on that also. And you can increase the Cronbach alpha by adding more number of items to your questionnaire. So this is a property of specific sample. Again, I said that Cronbach alpha is not of a scale, rather than reliability is of a test score, because it will differ from one population to the other population. So reliability is not, it never reflects the item reliability, and it is unique for each sample. Like you were asking the Cronbach alpha just now. So Cronbach alpha is not for the item. You can calculate the correlation of each item. But Cronbach alpha is for whole population, means the scale score of that population. So it is unique for each sample, and it is not universal for all circumstances, and it varies from sample to sample. Therefore, it should be estimated every time you administer the questionnaire. So interpretation of Cronbach alpha is like, if it is more than equal to 0.9, it is excellent. If it is 0.8 to 0.9, it is good. If it is 0.7 to 0.8, it is acceptable. So at least it should be 0.7 and more than that. Less than that, it is not acceptable at all. So there is something known as the standardized Cronbach alpha, when Cronbach alpha is based on the standardized item. And then there is another term which is the corrected item total correlation. We will see this concept when I'll show you the reliability analysis. So it is the Pearson correlation between the specific item and then rest of the other item. You make a sum of that and you get all this in the statistical package. So the Pearson correlation between that specific item and rest all other item is known as the corrected item total correlation. And if all the items, that means you assume that if this correlation is high, corrected item total correlation, that means that that item particular is measuring the same construct. So the what value we take? So cutoff we take as 0.3. So the Pearson correlation coefficient, it should be more than equal to 0.3, rather it should be more than 0.3. If it is less than that, then you can consider removing that item from your scale. And if it is negative, then you need to reverse code your item. That we'll see. Now there is something known as the squared multiple correlation. So it is the same R square value, what we know in the multiple regression. So that much coefficient of determination, you say that much variance, you can say the predictor variable is doing in that dependent variable. So to reduce the burden on respondent, we should use the brief version of scale. But this is a good idea. So I think so. Is it a good idea if you just to reduce the respondent burden, you should use the brief version of scale? Is it a good idea or not a good idea? Yes, only for the sake of reducing the burden, you should not sacrifice the number of items. Now coming to the another concept, which is the McDonald omega. So in Jamovi and in JASP, you have another measure of internal consistency, which is the McDonald omega. So McDonald omega is an alternative of Cronbach alpha, and it is a more accurate measure because it is independent of dimension. Like you can have one McDonald omega for a scale, but for Cronbach alpha, you need to have Cronbach alpha for each of your dimension. So it assumes that there are no residual correlations and all the items have identical loading. We will have understanding of loading in the factor analysis. So till now you can ignore this part and you can only remember that McDonald omega is an alternative of alpha, which is superior to alpha, which is dimension independent. So what do you understand by mean score of total scale? So mean score of total scale tells regarding the approximate response of all items in a scale. So if in a scale there are 12 items and all items are like in a 5-point Likert scale, where one says strongly disagree to strongly agree. If mean scale is 4.1, so can you say that most of the responses on the scale are on agree side? Can you say that? Yes. So there is a table of the mean score. So that only shows that how your population is responding on that particular item. So again, we know that even both the validity and reliability, that is the test score. I think this I will show. Now coming to the this part demonstration. So all of you should have JASP and Jamovi, both, because I will demonstrate on both. Those of you who know Jamovi, that is okay, because JASP and Jamovi are both same. Only the confirmatory factor analysis, you will see that JASP has better options. Otherwise, in all contexts, they both are same. So I hope all of you have downloaded the JASP and Jamovi. So I am showing first on JASP and then I'll show on Jamovi also. Yes, anyone who has not downloaded, because you need in the breakout room, you need to share your screen. So just what you have to do, go on window type JASP. I'm doing once again for you people, open this JASP. So before I tell you these hands-on, are you people like have understood me? Am I on the same page as you, or we all have understood? Or do you want me to repeat any concept? So Aditi is writing, I do not have Jamovi. Okay, I think one of the participants, Naveen, are you there? You can post it, or anyone can post it in the group, the link. Directly you have to go to Google. I'll show you here how to download it. It can be downloaded directly. I'll tell you, Haripriya, again, while doing the hands-on, how this McDonald Omega is different from the Cronbach Alpha. Okay, because let me show now. So this is the JASP interface. You can see there's a new data. Click on new data, and then you can see these 4 lines. Click on these 4 lines, and then you can see option of menu. In this menu, come to this computer. Okay, and in computer, you can see option of browse. Again, I'll repeat, open JASP. There will be a option of new data here. Click that new data. Click these 3 parallel blue lines, and then open. Click the option of open. Go to computer. Click on this browse. If you click on this browse, you show the path. Like my path is this, like data pilot testing. Again, Jamovi can import all data form like SPSS, SAS, Stata, Excel sheet, CSV. But JASP can import only CSV file. So we have shared CSV file to you people. And this is the data which you people have taken the response. Yesterday, we asked you to take the response on Toronto empathy scale from 5 to 10 people. So we have total of how many responses?
160, 70.
So we had total of 160 responses. Out of that, we have extracted initial 30, assuming that you are doing it for pilot testing. I'm sorry, for pilot testing. And then we are calculating the Cronbach alpha on those 30 samples. Oh, is it 50? Okay, 50 samples, which, so initially we extracted 50 data. And now I am extracting that CSV file. So you can write this open. And many times it hangs also. I have selected this CSV file. And then you will see that you have to wait for some time.
The input.
Again, I'll repeat, open, computer, browse. This data is there in my CSV file, open.
ये नहीं, उधर open हो चुका है।
Okay, this is,
नीचे देख, ये तो है।
so this is the data. It got open. You can see it is with the name like who has collected the data. And then I can do the analysis. So this is regarding the importing. Yes, solid version. Now coming to the analysis, you can see there are various options, but we will go to in this reliability. So if you click on the reliability, okay, yes, you might not get this reliability. So can you see this plus sign here? This plus sign. All of you, please just be with me when I'm showing. And then when you go to the breakout room, you have to practice. Can you see this plus sign? All of you. I can't see the responses. Yes. Okay. So when you click this, you will see that it is there alphabetically. So this reliability will come under this R. So if you keep on scrolling down, You can see it is there. So just click this and this will appear here on your task menu bar. This one. Okay. So you click, I think factor, it is there since beginning, factor. Factor is there, reliability you have to click. So I will open this reliability, and there are two types of reliability, Bayesian and classical. We will go to this classical unidimensional reliability. So I will open this. Then what I will do, I will move all these responses from this one. Yeah, that was a general question. You can see here, they are the nominal variable. It should be ordinal. So from 1, because we can perform it only on ordinal, means continuous scale. I will press Shift, select everything, and move this to this window. So this will tell you the McDonald omega and Cronbach alpha. If you see this analysis, here you can say it tells you this omega, but I will click the coefficient alpha also because I want the alpha also. So if you see the value, it is very low. What is the value of Cronbach alpha and McDonald omega? It is 0.2. So the scale is not reliable, and it gives you the 95% confidence interval also. So not reliable at all. But again, it is saying that the following items are correlated negatively with the scale. Item 1, but the scale is saying, if you, this software is saying, if you go to the scale, this is the Toronto empathy scale, which we have given. So if you read there are scoring instructions also on the scale. So scale is saying that these are the items which are negatively worded. 2, 4, 7, 10, 11, 12, and 14, 15. So I will reverse code these items. So I'll go to this JASP. This is many files. Let me close this one. So I'll go down.
Yes.
This is not going down. This is the reverse scale.
Yes.
Window minus.
Easy.
So this is so which item I have to reverse scale? Item number 2, item number 4, item number 7, 10, 11, 12, and 14. So I'll select 10. I'll press Control, 10, 11, 12, and 14, and 15. And move this to this place. So these were the questions which I need to reverse scale. So if I did that, then what is the McDonald omega now? Yes, all of you? Or Cronbach alpha? What is the value? Is it acceptable? Is it reliable? Seeing the cutoff which we have discussed, can you say that the test score is reliable? Yes. So you can see that if you don't reverse scale your item, and the reverse scaling you need to see from the initial scale, from this scale. Remember, if you read it, it is showing that the following negatively worded item are reverse scored. And I have just, what I did, I have moved these 2, 4, 7, 10, 11, 12, 14, and 15 here in the section of reverse, you can see there is a reverse scaling. So you need to move these items here. So if you have understood up till this point, so you can see it gives you your overall. Now coming to Haripriya's question, Haripriya was asking the difference between the Cronbach alpha and McDonald omega. So one thing is that McDonald omega is a superior measure than the Cronbach alpha because the underlying principle of calculation, which is the correlation and covariance, it has got a better measurement, McDonald omega. And coming to the dimensionality concept also, if the scale is multi-dimensional, then if you have developed a scale from scratch, you don't know regarding the factor or the dimension. You consider all scale initially as a single dimension. So in that case, Cronbach alpha will not give you a true reliability because you need to calculate Cronbach alpha for each factor. That we will see when we will see the factor analysis. Because in factor analysis, it breaks you into the multiple domain and you need to calculate the Cronbach alpha for each of these domain. So this is the limitation of Cronbach alpha. It considers all these scale as unidimensional, but it doesn't work in the unidimensional. If the scale is multidimensional, then it doesn't give you the true picture. So you need to have those many Cronbach alpha as a number of dimension. But McDonald works irrespective of dimension. So it is a better measure. Have you understood, Haripriya? Okay. So if you have understood this, now coming to another question which Dr. Latika asked regarding the individual item. So here you can see that this reliability you get overall reliability. Now there are individual item statistics. So it gives you the McDonald omega and Cronbach alpha if that item is dropped. What do I mean by that? So I'll click all these three and then you can see there will be appearance of a table. No, it should give no. But why this table is not appearing? It is taking some time.
Again, check करके देखो। हाँ, आ रहा है।
And now it is coming. You can see it is moving. नहीं, network का नहीं है।
वर्डप्रेस से उसको चेक करके चेक कीजिए, पता चलेगा, रिफ्रेश करिएगा।
Okay, let me, Dr. Shamshad is asking me to again. Let me check and uncheck. Okay, till the time it appears, let me show you in Jamovi. So this is the Jamovi file. It has not appeared yet.
बहुत सारा फाइल खुला है।
Oh, that's what I was saying now. Let me close all the file. So I've closed all the file. Don't say. I guess my system is working a little slow. It is taking time to. इसका विंडो भी आ जा रहा है पहले में. Let me close all the files probably.
नहीं होगा इतना टाइम डाउनलोड करने पड़ता है.
The movie is also taking time. I should have opened it.
मन कीजिए.
Yes, so now it has appeared since I have closed all the files. So you will see that, yes. So now can you see these items? Now how to enlarge this? Yes. So now this is your output view in JASP. So now focus one by one. So this is the first, focus on this first column. So this is the McDonald omega or Cronbach alpha. Both interpretation will be same. If you drop this item, then the McDonald omega will be 0.841. So what is the initial? 0.844. Now, please see this carefully. All the McDonald omega, the value is more than 0.8 even if you drop that item. So you don't need to drop the item. You take this decision if you drop that item and your McDonald omega or reliability increases very much, then you may take decision to drop that item. But if it is only a 16 item scale, already it is a small version, then you don't need to drop any item by seeing the value of McDonald omega or Cronbach alpha. Similarly, this is the item rest correlation. What do you mean by item rest correlation? I said that the value should be at least 0.3 and more than 0.3. So it says that the correlation between this item, the first one, and rest item total. So this particular item plus rest total score of the rest item and correlation between these two. So if you see the value, the second item, if you see this, the second item is 0.05. It is very less. It is less. Again, if you see, this is also less. And then rest all are okay. So these two items, item number 2 and item number 9, these two items are not showing a good correlation with rest of the item. Okay, so you can, but even if you drop this item, then there is a slight increase in the McDonald omega. Can you see? Initially it was 0.844. After dropping this will be 0.855. And this will be again 0.852. Okay, so if you drop these two items, there will be a slight gain or marginal gain in reliability. And the item rest correlation is below the cutoff. The cutoff we set at 0.3 and it is less than that. Coming to the mean score, if you see the mean score of these items is 2.43 and so, and you know how we interpret, but don't need to interpret, you just need to give this table as an output in the reliability and report the overall McDonald omega and Cronbach alpha along with 95% confidence interval. And here the lower boundary of 95% confidence interval is important because the lower boundary is above the acceptable level. The acceptable level is 0.7. It should not have less than 0.7. So even the lower margin of the confidence interval is above 0.7. So you can say that the scale is reliable. Have you understood up till this point? Dr. Latika?
Where is the confidence interval here?
Yes, ma'am, understood.
This one. Is it okay to everyone?
Ma'am, over here, if item rest correlation of these question 2 and question 9, if we find like if we have developed a scale and we are finding something like this, but it does not disturb the McDonald's omega,
Yes.
so we should keep it.
Yeah, what we do generally, if item perform, we only report. But we say that since there is only marginal gain and scale is already 16 item, it is important when your scale is like 50 item. Then you
Okay,
might
ma'am.
take a decision to delete that
Sure.
item so that you will gain over the respondent burden, number of items. But if the number of items are already less, then you may take a decision to continue with the item.
Okay, ma'am. Thank you.
Priyanka is writing if it is less than 0.7, then you need to take more sample because we have only calculated it in 50. Then you might say that if you increase the sample size, then it will go beyond like more than 0.7. Have you understood? Then I think Jamovi, again, it is very simple. This is the same interface, no difference at all. Let me see if the file opens. Otherwise, the mentor can show this in the breakout room.
Ma'am, their item correlation should be more than 0.3, as you said.
Yes.
So what to do if those items are with less correlation, we can delete, or what to do with them?
You can decide if your item is already of 16 questions, then you can keep those items. If you have got a very lengthy scale and you want to delete some item, then you can delete it. So this is the Jamovi interface. This you can see here. You will find it in, I go in factor, here it is in the factor analysis. Like there in JASP, reliability needs to be added. But in Jamovi, it is there in the option of factor. So if you click this, again, these are the items. I will press shift from item number 1 to item number 16. I've moved these items here. Click the McDonald, standard deviation, scale statistics, this Cronbach alpha, mean, standard deviation, item rest, correlation. And you see that it doesn't give you 95% confidence interval. Let me see. Scale mean. It gives you Cronbach alpha 0.29 and 0.4. But you know, we have not reverse scaled the item. So again, if you see the correlation heat map, it will not come. So let me show you I need to reverse scale. So what were the item? Let me select. It was 2. I will press Control 2, 4, 7. Then I'll go down 10, 11, 12, 14, and 15. I have moved this to the reverse scale. And then you see that the Cronbach alpha and omega, this McDonald omega, it has increased 0.84. But this doesn't give you the 95% CI. No, this option is not there. It is not there. So that is the difference. In the JASP, you get 95% CI. And this is the other. Here it tells you again the same mean, standard deviation. This is item rest correlation. You can see there can be minor change in the values. You can see, but again, the same items. And this is the Cronbach alpha and McDonald omega if that item is dropped. So what is your this thing? Do you want to go ahead with breakout room today or should we do it on Monday? Start with breakout room. I think Dr. Latika, it will mostly get rectified with completion of study. Yes, it will be. Yes, what is the participants' choice?
Today, madam, today.
Okay. What about others? Do you agree? Should we open the breakout room now?
Yes, ma'am.
Okay. So please open. You please open the breakout room. This data has been shared with you. If you
Okay,
practice
ma'am.
that, then it will be okay for even if you do it in Jamovi or JASP. Interface is same. You have just seen. Apart from few minor changes. Okay, there are people who are saying Monday also. So those of you who want to stay back, do it. Okay, one person, Tandra is saying Monday better. I don't know. Shivam is again.
Ma'am, what is the mean and standard deviation column you show?
That I said, na, remember I show you mean of item. So if it's saying 2.4, that means most of the people in your population have given a score of 2.4 to this scale. That means what is 2.4? If you see, go to this scale. So the first item 2 means sometimes. Okay. So most of the respondents have answered between 2 and 3. So between sometimes and often. That will be the interpretation of the individual. But generally you don't write individual. You just present it in the form of a table. Overall score, you can here the mean of, there is a mean of overall scale. It is, can you see this? 2.9. So it is nearly 3. So you can say that most of the respondent has answered 3, means often. These questions, they have answered often. That will be the interpretation. But generally, these are there, but we report basically the Cronbach alpha. And we report the item rest correlation. It is there for academic purpose, but we don't write it in the interpretation regarding the mean and SD. Monday, many people Monday. So what we can do, we will open the breakout room. Those of you who want to do it now, you can do it now. Otherwise, we'll repeat the exercise on Monday. Is it okay to everyone?
Okay.
Okay. So how many breakout room? 15 minutes. We will open the 2 breakout room probably or 3. How many we should? Open the breakout room. Akash, don't join.
Yes, okay, ma'am. 4 breakout rooms are there, ma'am.
Okay.
Okay.
So we will let's keep it for 15 minutes.
Okay, ma'am.
So request from participants. So 1 or 2 person can share the screen. It might take time to open the JASP and Jamovi. So close all your files on your computer. Like it took time for me also. Have you seen? It was taking time. It was not opening. If there are too many files opened on your computer, it gets slowed. So you close all your files and then open it. Okay.
Excuse me, ma'am.
Yeah.
Ma'am, in table 1, where we initially calculated Cronbach alpha and McDonald omega, just below just the footnote is written that table, just below the table that item number 9 needs to be reverse coded.
Actually, what it does now, this scale, this software doesn't know who are the items who are reverse scale. So it
Okay.
does opposite to what has been given. So you don't go by what this software is telling. You go by the initial scale direction, which I have seen from this.
Right, ma'am. Yes, ma'am. The initial question at the
Yeah, this one. It will do opposite. Why? Because 9, for them, 9 is the positively worded. So it has taken the reverse of this, but don't see that because then it will be a confusion. It is saying you in respect of the other set.
Ma'am, I thought that the ITC for 9 was 0.05, so that is the